All right, so today we're going to look at section 1.4, which is on solving absolute value equations. Okay. So, I don't know if we've talked about absolute value a lot. We might have reviewed it like the first day in the survival guide, like absolute value. But did anybody remember the symbol that you use?
Or if we were to write the absolute value of x, what would it look like?
Yeah.
What's the Hager writing?
Isn't it like the two lines?
Yeah. So those two vertical bars. Okay, so if you want to write what absolute value looks like, you put those two bars.
If you want to put it on there, you can. If you know, you have to.
If you already know that, you don't have to write that down. I think the first thing you guys have is
The
absolute value measures.
We haven't got to that yet. I should say like 2 was Hager. 4, I'm sorry.
So how would I do this one? If I wanted to write down a problem on a test, and I wanted you to take the absolute value of 4, can someone tell me how that would look? Yeah?
You would do the 2 bars on either side of the 4.
Yeah, you put 2 bars on either side of the 4, and what would be the answer to that? What is the absolute value of 4? Yeah? 4. Now, what if I did this? What's the absolute value of -4? Yep.
4.
It's still 4. So what does that tell you? When you take the absolute value of something, you always get what kind of number? Always positive. And that's because absolute value measures a distance.
So guys, the only thing you have to write on your notes is just what's highlighted. Distance from 0. That's what absolute value measures. Distance from 0.
Hey, think about distance for a second. If you measure the distance from here to the back of the room, it would never be a negative number, right? Distance is never negative. If you measure the distance from here to Boston, you would never say it's like -40 miles or -50 miles. It's 50 or 40, right? Whatever it is. So distance is always a positive number. So think about it that way.
And if you looked at it on a number line, right? Here's 4, it's 1, 2, 3, 4 spaces from 0. Same thing here. If I look at -4, it's 1, 2, 3, 4 spaces from 0. Just to see it visually, that's how it works. Okay?
So what we're going to do is we're going to look at equations that look like that. Okay? We're going to look at equations that have those bars in them. So whenever you have an equation that has the bars in them, that is called an absolute value equation. Right? That's all. Equation with bars, it's called an absolute value equation. When you're solving it, there's 3 things that could happen. Okay? You could end up with 2 solutions, which is what's going to happen most of the time.
Yeah.
You could end up with 0 or 1 solutions. Okay, it depends. Do we do a 0 solution?
I don't think so.
We don't do one? All right. So most of the time you're going to end up with 2 solutions. All right.
So guys, when we're looking at this, right, for our steps, all right, you have on your notes, right, you have the first thing you have for your steps is ensure. All right? So what you want to write is ensure the absolute value expression is by itself on one side of the equal sign. So, squeeze it in. You have your equal sign. Here's the absolute value bar. That's you want stuff inside of it, nothing outside of it. Right? You don't want anything. You don't want like the absolute value bars. Here's the absolute value bars plus 3 equals 7. If you had something like that, you had something, say if you had like x plus 5. And the absolute value bars plus 3 equals 7, you wouldn't be able to solve that yet because the absolute value bars aren't by themselves. It's kind of like, think of the absolute value bars, like what's inside of it, almost like one big variable. You want to get that alone first, then you can solve. So if this stuff connect, like, or you might, and again, you'll see some of the different situations you could have for stuff outside of it when we go through these steps. But the big thing I want you to understand is the absolute value bars on either side of the equal sign have to be by themselves. It can't be plus or minus a number. They can't be a number, you know, it can't be like this, 3. Couldn't be like that either. See, we have the 3 attached to the absolute value. You couldn't solve yet because the absolute value is not by itself. Once it's by itself, then you can solve. So we'll just go through some of those situations you could get when there's something attached to it and what you need to do to get it by itself. All right? So if there's a number attached, like I showed you up here, we'll have a little bit of space to put your example too. But for example, something like that. There's a number attached to the absolute value. So up here we got a 3. All right? You're going to divide both sides of the equal sign by that number. And again, we'll do an example in a second, so it makes a little bit more sense. If there's a number attached to the absolute value, there's no sign in between, just a number and the absolute value bars. You'll divide by the number that's attached to the absolute value. Just like we're in the last step of an equation. We have like 3x equals 6. We would divide to get x by itself. Same thing here. We want to treat what's in the absolute value bars like a big variable. Get it by itself first, then you can solve. If there's a number attached, we'll divide. So for example, if I had something like this, so there's your example, where we have a number attached to the absolute value. All we're going to do is just divide by 3. That will get rid of what was attached to the absolute value. It'll get it by itself. That way, absolute value bars don't go away at this point. They stay. I have them by themselves. I can get ready to solve. So at this point, I would be ready to solve that absolute value equation because I got rid of what was attached to the absolute value bars. There can be nothing attached to it, and again, I'll show you one in a second here where with this plus or minus a number with the absolute value. It's on the same side of the equal sign, right? So again, that's ready to solve. So these are some situations you may have before you can solve. When there's something attached. Before you can solve, you have to do this stuff. Another situation you may have, if you have a number attached to the absolute value, like we had up here, with the 3 and the x plus 5 equals 6, and another number, again, when you see the example in a second, it'll make sense. Do the opposite operation. So it's like, again, when we want to get an equation by itself, like we have, about that. Again, we want to get it by itself, so we subtract, then we divide, then we subtract, add and subtract, and then we divide, like 3x plus 2 equals. Right? So I minus first, then I would divide. I'm just trying to show you guys that I know that there's going to be numbers inside those absolute value bars, but the steps you take to get it by itself is just like solving an equation. If you think of what's inside the absolute value bars as a big variable, again, to get it by itself, you do the same exact steps. I know it's kind of weird to think that way because all these numbers inside the bars, but at first, if you think of it as one big variable, it's going to make it a little bit easier to move stuff around and get it set up. So again, that's when you have a situation like this, and I want to show you guys the example, it'll make a little more sense. But this is about as hard as it gets, because you're going to move 2 things first before you can solve. All right? I know some of you guys are still writing. I'll have some of you guys take a look at what we have here. So here's my, again, plus or minus a number and a number attached. So I got plus or minus a number on the same side as the absolute value bars and a number attached. So again, if let's see if I can do this.
That what you're trying for?
Yeah. If I treated what's in there, oops, I treated that like an x, right? What would I do? What would be the first thing I would do? If it was 6x minus 14 equals 10. What would I do first? What would I do, Laurel? If I wanted to solve 6x minus 14 equals 10, what would be the first thing I do? Donovan?
Divide both sides by 6.
Not yet. That would be the next step. Not yet. This was 6x minus 14 equals 10. What would you do? Chris?
You add 14.
I'd add 14 to both sides, right? Plus 14, plus 14. Then I get my 6, absolute value, equals 24. What would be the last thing I would do? Okay. Divide by 6. Divide both sides. So I'm just trying to show you guys that if we treated what's inside the absolute value bars just like a variable, it's the same exact steps. Again, I know it looks a little overwhelming because there's numbers in here, but if you treat that as one big at first, you get a situation like this where there's stuff to the left of it, plus or minus a number. If you think of it as one big variable, you're going to get it by itself the same exact way. All right? At that point, I'd be good to solve. So again, there's some situations where the absolute value bars may already be by themselves. There's nothing attached, there's no plus or minus a number, you can just go ahead and solve. But there's some of them where there may be, like I said, a number attached. There may be this. It could be this too. Something like that. I got no number attached, but I would still have to plus 5 to get the absolute value by itself. All right? So again, those are the situations where the absolute value is not by itself, so you can't just go ahead and solve. You got to take a few steps to do that. All right? Next thing. Next step. Now, the absolute value bars are by themselves. And like I said, you may get that right off the bat. Sometimes you don't. Depends on what kind of a problem it is. All right? We'll eliminate the absolute value bars. We're going to split the original equation in 2. All right? But again, we can't do that until the absolute value bars are by themselves. All right? And there's kind of like a little diagram on there, guys. We're going to fill that in just a second. All right? I think it's easier to see it visually as opposed to me like trying to write it out and explain it. I think if you see it visually, it'll make a little bit more sense. So once the absolute value bars are by themselves, we'll split them. When we split them, that gets rid of the absolute value. The bars go away. Once I split them, the bars go away. Like I call this part like you're breaking out of jail. You're splitting it, you're breaking out of jail, no more bars. All right? But again, they have to be. The absolute value bars have to be by themselves. There can be no number attached, no plus or minus. They're going to be by themselves. Just the bars. Bars equal sign number. That's all you can have. So this is it. This is your original, right? bars, equal sign, and there'll be a number here. When you get it like that, you're good to solve. But like I said, sometimes you may get that. It might be all set to go and split. Sometimes it may not be. All right? So when you split it, make sure, so right below your little bars there, make sure when you split it, all right, once you split it, it's going to be written with no more absolute value bars. You'll take what's here, you're going to have two problems now. All right, and I'll explain what they're going to look like in a second. But again, when you have them, there's no more absolute value bars. So you may want to write that right there, written with no absolute value. So here, when I do it to one side, I'm going to have my original equation. The only thing that's going to be different is no absolute value bars. The numbers, the variables, everything else is exactly the same. The only difference with your first equation is going to be no absolute value bars. All right? So the first one's easy. It's pretty much exactly the same as what you have originally, but again, this is no absolute value bars. The second equation that you write is a little bit more difficult, but not too bad. Again, no absolute value bars, and whenever that absolute value equation equals, change it to negative. So if it equaled 3 in the original, when you write this, your second equation down here, make sure it's negative 3. If it's 5, make sure it's negative 5. So the first one's exactly the same with no bars. The second one is no bars and make the number it equals negative. So it's a little bit more for that second one. All right? Now, third thing. So again, you have all this stuff, guys. You just have to write original and change the number after the negative. So you have your arrows, right? Under the first arrow, it's going to be basically the original with no absolute value bars. Your second one is going to be no absolute value bars and make the number it equals negative. That's it. So you have the little diagram on there. You're just going to fill in underneath the arrows. All right. Now we're split. All right. Make sure the absolute value bars are by themselves. We split it. Now we can solve. All right. The steps you do in this equation are going to be exactly the same for the ones you do for this equation. Whatever you do first over here is what you're going to do first over here. If you minus 2 over here, you're going to minus 2 from both sides over here. The only thing is your number here, when it equals, will be different because it's going to be negative. Right? You're not going to get the same answer, but the steps will be the same. All right? And again, like Mr. Hager said at the beginning, right? You could have 0, you could have 1, you could have 2 answers. In most cases, I'd probably say 95% of the time for the stuff we're doing today, and the stuff we'll do on the test on Friday, you're going to have 2 answers. X equals something and X equals something else. All right? So you almost always have 2 answers. You can't just go ahead and solve. You have to have 2. That's one place where people struggle with this. You've got to make sure that you have 2 answers. You just do the work for one, you're only going to get half credit. You've got to make sure you have 2 answers. And I think I wrote this on your thing, guys. I may not have. You might want to squeeze it in down the bottom. The 2 answers you get, all right, are connected with the word and. So if I got, you don't have to write this down.
Well, when it says answers connected by the word and.
Oh, it says on there? I wrote it on. Okay, perfect. You guys don't have to write that down. It'll be like x equals 3 and x equals negative 5. All right, so just make sure you know that the words are connected by the word and. All right? Good with these steps? Can I move on?
Yeah.
Matt?
And like towards the top, I missed number 1 like on the intro part.
You missed number 1 and 1 what?
Just the notes. Like I forgot to write it down.
So like this?
Yeah.
Okay, I'll give you a second. So again, guys, like I said, this stuff Like I said, some of these absolute value equations are going to be by themselves. You can just split and solve. Some of them, you may have to divide on both sides to get the absolute value by itself. You may have to subtract or add a number on both sides to get the absolute value by itself. You may have to add or subtract on both sides and divide. It depends on how the problem's set. Alright? All set, Matt? Everybody else is good?
Yes.
So here's the first one. Right? First question we have to ask ourselves is what? Someone tell me where raising their hand. What's the first question we have to ask ourselves? What are we looking for, Donovan?
Can you add or subtract on sides?
Is it okay? Basically, is there anything out? Is there anything attached to, or plus or minus on the same side of the absolute value? Do we have that, Donovan? Yeah. So the first question we're always asking ourselves is the absolute value bar by itself on one side? Is there anything attached? Is there plus or minus anything on the same side? No, it's by itself. All right. So what can I go ahead and do now? I'm on that step. I did step one, right? Didn't have to do anything for step one. The absolute value was already by itself. Mary?
Now you would make the two different equations.
I'm going to split them, right? This is, again, I want to break out of jail now, right? So I'm going to split them. What's my first one going to be? Mary, what do I write?
X
Yeah?
plus 1 equals 3.
Exactly. Again, no absolute value bars. When you split them, you're breaking out of jail, no bars. The second one is a little more tricky. What's it going to be, Ellie?
Did you do like negative 1x because like there's 1 in front of the x, or would you do like negative x?
I know what you're thinking, but we don't have to change that.
You don't have to change
You're
that?
doing too much.
Okay.
You only got to change one thing to
Only
negative.
1?
Nope.
Go on.
Karen?
X plus 1 equals negative 3.
Exactly.
Oh, okay.
X plus 1 equals negative 3. You're only changing what the equation equals to negative. Only what it equals is changing to negative. None of the stuff in the absolute value bars up here are becoming negative. The only thing that changes to negative is what the equation equals. That's it. Everything else stays the same. Alright? Guys, what I like to do is I like to split them both first, then solve. If you want to split it, do all the math for this one, and then come back and do that one, it's entirely up to you, but I would split them both first, and then solve one, solve the other. And Miss Hager just connected it with the word and. So again, now we can solve. Bethany, what am I doing? What's my first? The cool thing about this one is it's only going to be one step in both. What's my one and only step for this one? How would I solve for x? I want to get x by itself, right? So what's on the side of the equal sign with x? Plus what? Plus 1, right? So what would I do? I would subtract, right? X equals, so there's 1. I'm going to bring my and down. And like I said, the cool thing about it is the first step in this one is the first step in this one. So Jake, my first step in this one is my first step in this one. What am I going to do? I'm going to do the same exact thing I did to this one, to this one. So what do I do?
Subtract.
Subtract what number?
The 1.
From 1. I'm going to subtract 1 from 1. And what other number, Jake?
So
Negative 3. Jake, do you know negative 3 minus 1?
would be negative 4.
Nice job, buddy. Negative 4. Done. One step. Basic. First, and if there was another step here, the step I did here would be the same step I do over here. Let's see how it works out differently because we have a negative number here and a positive number there. That's why it works out a little bit differently. Sometimes we may ask you to graph it. Sometimes we may not ask you to graph it. Very simple. To graph it, all you do is find 2 on the number line. We go and open or closed on this. Closed. Closed. Put a dot at 2. Put a dot at negative 4. So to graph it, that's all you have to do is just put dots at the 2 numbers we had for answers. Alright? Because that means I could plug in 2. If I had to check it, I could plug 2 in for this equation and get a correct answer. And I could plug in -4. Both of those solutions would work. Because if I do, again, you don't have to check it. Let's show you guys how it works out. Oops. Again, keep the absolute value bars for now. Like we talked about in the warm-up, right? Or at the beginning of the lesson. The absolute value of 3 is what?
3.
3. It's still positive 3. 3 equals 3. It matches. Plug in -4. -4 plus 1. 3. I would get -3 here. Equals 3. Again, the absolute value of -3 is what? 3. 3 equals 3. It checks out. Again, you don't have to check them. I'm just showing you that both, because it's an and, both answers have to work for the variable. I could plug in both, and they would both work as answers to that absolute value equation. So again, that's why you have 2 answers. Okay? Can I move on from this? Okay? Oops. Again, this one. David, first question I have to ask myself is what?
Is there anything with the absolute value?
Is there anything with the absolute value on that left-hand side? What's your answer to that?
No.
There's nothing, right? So Matt, what can I do now? There's nothing outside, so I don't have to do any work, any extra work for this one. It's all set to go. You want to hit?
You gotta split it out.
Split it. Can you tell me my first equation?
2x plus 4 equals 8.
Yeah, that's I would say that's the easier one. Because what's the only difference from this one that we just wrote to the original? What's the only difference, Matt? There's no bars, right? When we split it, we're breaking out, there's no bars. Can somebody remind me by raising their hand, what word separates the 2 equations? And, right? Put my and. Somebody tell me my second equation.
2x plus 4 equals -8.
Good, nice job, Savannah. 2x plus 4 equals -8. That's a really bad 4. Only thing that 2 changes. For the second one, 2 changes. No bars, make it negative. First one, 1 change. Just no bars. Second one, no bars, make the number it equals negative. Nothing in the absolute value bars changes from that. The only thing that changes is what it equals. Make it negative. Alright? Alex, what's my first step in both equations? Subtract 4. I'm gonna do it in both. But we'll just come back to this one. We'll come back to that one later. Alright? This will cancel out. Gonna get 4 here. It's 2x. Alright? My last step. How about Catherine? My last step for this one. By what number? 2. Divide by 2. Divide by 2. X equals what, Catherine? 4 divided by 2. 2. Nice. I'm going to bring my and down. In my other equation, I got a -8 and a -4. Mary?
So you would subtract the 4 from each other to give you a -12.
Again, -12. Not 12, not -4, -12. Both sides are negative. Keep the sign, add the numbers together. Yusuf, again, we already did this step over here. We just got to do it over there. What is that step? Divide by what number? 2. X equals negative divided by a positive? -6, right? Cool. How do I graph it? Paige, how do I graph it? Somebody help Paige out. How do we graph? Savannah?
Put a dot on two and a dot on.
Yeah. All we're doing, Paige, is finding these. I know it's kind of like, it's really easy. And it might be hard to explain. It might be a little bit hard to explain. Again, because it's kind of like simple. Just find these numbers and put dots on the number line. That's how you graph it. Put a dot at 2. Put a dot at -6. That's it. That's all you have to do. Again, for these guys, we're not going to have you check them. I just checked the first one so you can see how it worked out with having 2 answers. And they both work. It's absolute value. All right? One more. One more basic one. Then we got 2 more that involve a little bit more work. So for this one, Nathan, what's the first question I have to ask myself?
Is there anything next to it?
Anything attached to it? Anything plus or minus? Is there?
No.
What's my first equation going to be? Sorry, Mr. Hager. Is it homework? What's my first equation going to be?
3x plus 21?
3x. I like 3x.
Or 3x.
Okay, am I clear to write on here?
Yep.
3x.
Divided by 21?
We will divide, but we're going to write it up first. Remember, all I'm doing is Nathan, all I'm doing is taking the first one. My first equation is just the same exact one up here, that's up here, just with no absolute value bars. Ellie, do you want to say the second one?
Yeah.
Tell me.
3x equals -21.
3x equals -21. Again, no bars, make it negative. First one, no bars. Second one, no bars, make the number negative. What's the step? Joe, what's the step in both equations that I have to do?
Divide by 3.
Divide by 3. Excellent. Divide by 3 here. Divide by 3 here. This one's going to be what, guys? X equals 7. The other one's going to be x equals -7. What's the word? And. Nice job. Again, graphing them, pretty simple. Just put numbers, just put dots at the numbers. You guys notice how Mr. Hager didn't write all the numbers. Again, as long as if you're going to do something like just put the numbers that you had for solutions, that's fine. Just make sure you put a 0 there so we know that you know negative numbers are on the left, positive numbers are on the right. And again, I think on the test, I think we give you a number line anyway, so it's already numbered, right? So that's how that works. Again, those are basic. Why were those ones basic? Somebody explain to me why.
Because it was like a one-step problem, pretty much.
Yeah,
It was,
again,
It was like right here. Like,
Yusuf, when are we getting to having to do extra work with these?
when you have like another number inside the orange.
Yeah, there's numbers outside.
Yes.
There's numbers like attached, or there's a plus or minus number on the same side. That's when you get into more work. These are basic. All right? They were all set to go. Split them. The first one, just no bars. The second one, no bars. Make it negative. All right? So this one, like we've asked ourselves for the first 3 examples we did, we asked ourselves, okay, are there any numbers on the outside? The answer for the first 3 examples we did was no. We're all set. But now, it's not as simple. Why is it not as simple? Savannah? We get the 2 attached to the absolute value. Alright? So to get the absolute value by itself, what do I have to do? Savannah?
I think we have to divide each side.
Yeah, divide. Like I said, treat it just like a big X. If this was 2x equals 4, you divide by 2. I know there's all numbers in there, and it's scary, and it's like, oh my god. But again, if we treat that just as one big variable, you'll get it by itself. So I'm just going to divide by 2. Divide by 2. All right? Here's my absolute value. I did this to get my absolute value by itself. It's going to equal what number now? 2. Now, if I go back, Look at example 1b. It's the exact same thing now. I just have to do one more step to get to that point. If there's a number attached to it, just divide on both sides. It's that simple. My first equation will be what? Ellie?
3y plus 5 equals 2.
3y plus 5 equals 2. I know I sound like a broken record. Alright? First one, no bars. Everything else stays the same. How about Melanie? What's my second one gonna be?
3y plus 5.
3y plus 5 equals -2. Now, Jelly, what's the first step in solving both equations gonna be? Subtract 5. Again, if you want to deal with one by itself, you can. If you want to do steps in both at the same time, it's entirely up to you what makes more sense to you. As long as you get the right answer, I don't care how you get there. Alright? Oh, I gotta make sure Mercedes is gonna get mad at me if I don't write. Alright, when I do this, I'm gonna get 3y equals -3. I did 2 minus 5. 5 is bigger, 5 is a bigger number. I take the sign of the bigger number, that's gonna be my answer. Last step here, I just divide. There's 1. Y equals -1. And again, I'm following the exact same steps over here. We already did the first step. 3y equals -7. If I'm not sure how to do this one, just look back to that one and see what you did. Alright, I'm at that second step. Alright, I divided over here. I'm going to divide over here. Y equals, we can make this, say, did you do that on the calculator? I don't even work on it. So -2.3. Most of the time it's going to work out to be nice numbers, whole numbers for this. But every once in a while you might get a decimal. So I get -2.3. So graphing -1 is easy. How about -2.3? How would I graph that? Helen?
Like 2, -2, and then like over 3.
I really can't go over 3. I'm not like on a coordinate grid, like graphing like slope. The jelly?
Can't you just have like, instead of numbers, can't you just have like decimals?
Yeah. Again, so I do have a decimal, -2 over 3. Where would I graph that in the number line?
No, like the numbers. You know how you can have -1, it could just be like. Yeah, so the little, so it'd be 2 and then 2.3, so it's a little bit over 2.
Exactly. It's a little bit over 2. It's not, is it right smack dab halfway in between?
No.
What decimal would that be? 2.5, right? So I almost want to be 2.5. That's all I kind of base it on. I'm like, all right, 2.5 is halfway in between. I want to be a little bit less than that. So I want to be right about there. Kind of, again, not quite halfway, but almost. Mary?
If we get this on like a test or something or on our homework, would you rather us make it a decimal or turn it into a fraction?
You can do whatever makes sense to you. That's fine.
would be easier to graph.
Decimal might be a little bit easier to graph, but if you feel comfortable with your fractions, you can do that too. Because you can make it a mixed number, and end up being like 2 and it'll be like -2 and 1/3. So if you made it a fraction, it looks like that. It looks like that. All right. So either way, I think you guys might be a little better off with this. Probably a little bit nicer. If you know how to graph that, that's fine too. All right. So again, a little bit more difficult because it had to get it by itself first. All right. Last one. So this one. First thing we have to ask ourselves is what? Dylan, we're doing these absolute value equations. What's the first thing we have to ask ourselves?
Oh, is there anything on the either side of the?
Yep. Do we have that here?
No. Oh, wait, yes, plus 5.
Plus 5. So what do? To get the absolute value bars by themselves on one side of the equation. Minus 5. Just like solving an equation, right? If it was x plus 5, you'd minus 5, minus 5. X minus 1 equals negative 3. I want you guys to take a minute or so, solve it. So you've heard me talk enough today. I want you to solve it, right, and graph it. What happened? Oh, what?
That's no solution.
Oh, okay. There's no solution. Guys, hold on a second here. Stop.
That's okay. That's a good problem to go over.
Yeah. This one, right? Say if I left this room, right? I had my Fitbit on, right? And I walked backwards. And I looked at the amount of steps that I walked. Would they be positive numbers or negative numbers? They'd still be positive, right? Even though I'm walking backwards. Or how many people have driven to like Florida before? Driven to Disney? I know my wife has, my in-law, my mother-in-law, my father-in-law, my brother-in-law, my brother has. You're driving south. You're driving down. When you look at your number of miles you drove, do they go down? No. Again, we're measuring distance. What did we say about absolute values? Aaron? Yeah, but absolute value measures what? Distance from 0 on the number line. Alright? Distance can never be negative. Like I said, that's what I was trying to explain to you guys. Even if I walk negative, if I walked around the building, I would still walk maybe a mile. Wouldn't be negative a mile because I walked backwards. Or if I drove south, I drove down. Doesn't matter, I'm still going to be gaining miles. Absolute value can never be negative. So if you have the absolute value bar by itself, and it equals a negative. Alright? Now you got to be careful, because you may get something like this. You don't have to write this down. I'm just going to show you guys something. This one, it equals a negative. But you gotta make sure it's by itself before you say whether it's a solution or no solution. Because in this case, let me say, you can finish up. If I added 3, it becomes, because I added 3, it becomes 2. This one would work, all right, because it equals, this is a positive. So don't just think because if it was like this, if I just had what's my answer?
Negative.
What's my answer, Aaron? No solution. If it's by itself and it equals a negative, the absolute value bars are by themselves. There's nothing outside of them, to the left or to the right. On that side of the equal sign. They're by themselves, it equals a negative, no solution. If you have something like up here, where yes, you have the absolute value bars, you have a negative, but hold on a minute, you got something to the outside. Do what you have to do to get the absolute value bar by itself. If it still equals a negative, there will be no solution. But like that one, it changed to a positive, so it would still be a solution. Alright, so you just got to be careful. So Mr. Hager said, because the absolute value bars are by themselves and equal a negative number, there is no solution. So if we got something like that, there'll be no solution. Alright? Guys, you can leave your notes up because I got a couple practice problems for you to do too.
No, I don't have space.
I didn't give you any space in the back?
No.
Okay, I'm sorry. So tonight, homework 1.4. I think there's 8 problems total. I think on the back side, the last 2, 7 and 8, are a review of what we did yesterday. They're distributed properly. Next, remember Thursday is going to be a review day. First half of class. First half of the class, we'll do a review, we'll do an FCAS question. Second half, we'll do a review thing. Remember, like Mr. Hager underlined, tomorrow's the last day of new stuff for this week. Alright? What we do Thursday is all review. So tomorrow's the last day of new stuff. We only have 3 days of new stuff this week. Alright? Remember, test on Friday. The reference sheet may be up this afternoon. If not this afternoon, it'll definitely be up by tomorrow at some point. If you guys want to get started on that, finding your examples, you can. Again, this is your last academic week before progress reports. Progress reports closed for you guys on Friday, so the test we took last academic week and the test we take this Friday will be on there. What else do I have on there? Again, guys, I want you to try these. Try these. Maybe not. There we go. Guys, let's grab a piece of scrap or whatever.